Okay, today we're going to look at some different integrals. This one here, 1 over x squared minus 4. How do we solve this integral? Because substitution won't work and integration by parts wouldn't work on this either. So what we're going to use is a way called partial fractions. We're going to split this rational expression into two separate fractions. And how we do that is first we're going to factor this. So if we factor 1 over this x squared minus 4 would factor into x plus 2 and x minus 2. Okay? So there must be some fraction then where we could write it as two separate fractions apart, because something must combine together to make this one fraction if there's two terms down there. Okay, the problem is we don't know what goes up here and what goes up here. And so what we're going to need to do is find that out. Well, if you think about how we would make this fraction into this fraction, is we would have to do some multiplying and get a common denominator. So what we're going to do next is multiply by what you would to make that common denominator. So here, this term would have to get multiplied by x minus 2 over x minus 2. This fraction would have to get multiplied by x plus 2 and x plus 2. Okay, well, now that we have the same denominator all the way across here, this one's the same, this is the same, this is the same, we know if we would multiply through by that, that would be gone. And what we have now on top is a equation that if solved, we can figure out what that a and b are that would make that equal 1. There's a couple ways we can do this. I'm going to show you both ways. One's a little bit easier, but I want you to kind of see how this works here. So what we would do is distribute here. Also distribute here. So we're going to distribute through. So now we got ax minus 2a plus bx plus 2b. Okay, and so what we're going to do now is group together our a terms, or our x terms, and our non-x terms, our variable terms. So I'm going to put these two next to each other, and I'm going to write these two next to each other. Okay, and then what I'm going to do is on this one I'm going to factor out the x. So if x were to be factored out here, we would have a plus b. Okay, and then I'm going to group these two together too. Okay, so now over on this other side, we have a 1, and we don't have any x terms over there, so it's like there's 0 x's over here. Okay, so now if these two were going to be equal to each other, what we would have to have is that this would have to equal 0, and this stuff, because it doesn't have an x, would have to equal 1. So what we're going to come up with here is two different equations. One's going to be that a plus b we know has to equal 0, and the other one is that negative 2a plus 2b has to equal 1. Now we have a system of equations that we can solve out on our problem. Okay, you've done these before. We could, one way to solve this would be to multiply the top one by 2 there. So we got 2a plus 2b still equals 0, because 0 times 2 would be that. Now if we combine that with the bottom term, those cancel, we get 4b equals 1, and b then would equal 1/4. Now if we plug it back in, say to this top equation, we can also find a. So it looks like a equals negative 1/4. And so those are the two terms then that we have for a and b. So now we know this. If we go back up here and we write this out again, another way to write 1 over x plus 2 times x minus 2, that's equal to negative 1/4 over x plus 2, because we're just putting negative 1/4 in place of a, plus 1/4 over x minus 2. Okay, so now what we're going to do is use that, okay, to integrate this. Okay, so we're gonna change our integral to kind of match what we had there. Okay, so how that works now is, let's set up our integral to the same thing. So our integral before was 1 over x squared minus 4. We're going to change that to the partial fraction of negative 1/4 over x plus 2 plus 1/4 over x minus 2. And that might not look better, but it actually is, because now that we have two separate ones like this, we should be able to integrate them both. It might look easier if we split this into two integrals, and we can do that because we got a plus here. So I'm going to pull the constant out. This would be 1 over x plus 2. The other one, I'm going to pull that constant out too. This would be 1 over x minus 2. Those are actually pretty easy integrals now. The antiderivative of this one would be natural log of x plus 2, because it's 1 over x basically, with our constant. And then the other one, very similar, is going to be natural log of x minus 2. And now we've integrated that using partial fractions. That would be the answer to the problem. All right, let's try another one here. We're going to use partial fractions on this. So similar, we're going to try splitting this one up here. So first thing, okay, factor that bottom. So we get, looks like we can pull an x out there. Okay, so now we're going to try to split this up here into two fractions, one with a denominator of x, one with a denominator of x plus 5. Okay, and on top we're going to put our two constants that we're not sure of. Okay, so now partial fractions, we're going to figure out what we'd have to multiply by to get common denominator. Here x plus 5, so the top's got to get multiplied by x plus 5. Here x, so the top would have to get multiplied by x. Okay, now we just want to solve that top. So we got 2 minus x equals a times x plus 5 plus bx. Okay, now we could do a very similar to the last one and go through and set up a system of equations. I'm going to show you an easier way though that most people use on these ones. We're going to figure out what are the two numbers here that would make these equal 0, and it's kind of a cheat way to find it, but it works. So one number here that would make these disappear would be if x equals negative 5, because if we put negative 5 in there, that makes that equals 0 and gets rid of the a. So we're going to figure out at x equals negative 5, what does this whole equation end up equaling here? Okay, well, so what we're going to do is plug in negative 5 everywhere. So we're going to plug in negative 5 here for this x. We're going to plug in negative 5 here for this x. And we're going to plug in negative 5 for this last x here. And what you're going to see is a lot of this stuff simplifies really fast. So on this left side, this would end up being 7. This is just going to be 0 here, so that's gone. That term's eliminated, and we'd have negative 5b over there. So now what we want to do is just solve for b, and we find out that b is going to be negative 7/5. Okay, so similar now, we're going to try to find what's the other number that would get rid of one of those. And the other one would be 0, because if we were to put 0 in for this b, that just eliminates, or that x, that eliminates that b term. Okay, so we're going to also find this at x equals 0. So everywhere there's an x, we're going to plug in 0. So that equation would end up being 2 minus 0 as 0 plus 5 plus b times 0. And again, this term, last term cancels out, so we'd have 5a being equal to 2. And so now we can find out what a is. A is going to be 2/5. That's a lot easier than having to go through and do a system of equations. So that's kind of the way that we're going to use from now on because it goes a lot faster. So now what we're going to do, go back and solve out this integral. We're going to split it up into separate fractions now in order to do this. Okay, so this integral of 2 minus x over that, we can split up now into our partial fractions. Okay, so I'm going to kind of erase what we had multiplied here. We now know what our a and b are. Okay, we got an a that came out to be 2/5. So we're going to put 2/5 here. And we got a b that came out to be -7/5. And we want to integrate this. Okay, so again, if we just pull out that constant on each one, now that one looks like this. We can think of this one as a separate one over here. -7/5 is the constant we pull out. Those are super easy to integrate now. This one's going to be 2/5 natural log of x. And our other one here would be natural log of x plus 5 plus some constant. There's our answer. Okay. So once you've split it into partial fractions, it's a lot easier than to go through. All right. Why don't you pause the video, see if you can try this one on your own. All right. If you split this, factored and split it up, you should get something that looks like this. Then multiplying to get the common denominator, you end up with what we got here. The two numbers that are going to make this equal 0 would be 3 and -2. So if you plug 3 in for all the x's, the left side ends up being 20. The right side ends up being 5a. If you solve that, a ends up being 4. The other number would be -2. So -2, if you plug that in, the left side becomes 5. The right side becomes -5b, and you find that b equals -1. So let's plug those two numbers in here now. And our integrals would become 4 over x minus 3 plus -1 over x plus 2. Now if we integrate, we would get 4 natural log of x minus 3. And I'm going to put it as -1 here, -1 natural log x plus 2 plus some constant. That would be the antiderivative. All right, this next one, let's use partial fractions to integrate here. So in this one, again, we want to do some factoring on the bottom, kind of see what that looks like. So if we factor this bottom out, looks like first we could take out an x, and we're left with 3x squared plus 4x minus 4. Okay, it looks like we can factor that further. So this one should still be able to be split up again. We know there's going to be a 3x and an x. And what's going to times the -4, and when we multiply through, add up to 4 there. Let's see, I think we could do that with a +2 on this side and a -2 on this side, because now we got 6x and -2x, and those add up to our 4x. All right, so once you got it factored, now we want to split this into partial fractions. Now this one, we're going to have, looks like, 3 of them on the bottom, and that can happen. So now what we got to figure out is, what would this equal? Here we'd have some term over x plus another term over 3x minus 2, and a third term here of x plus 2 if we split it up into partial fractions. Okay, but we know all that still would have to equal here our x squared plus 4. So what we got to solve to figure this one out now is x squared plus 4 would have to equal. Now, if we're going to make this a common denominator here, this first term would have to get multiplied by this one and this one, the other two that it's missing. So we'd have a times 3x minus 2 and x plus 2. Okay, plus b. Now the b one would have to get multiplied by this one and this one. So x plus 2. Okay, finally this last term c would have to get multiplied by those two. So x and 3x minus 2. Okay, now we're going to use our little cheat way here to figure out what are the a, b, and c. So first off, if we'd, one of the numbers here that would make this equals 0 would be like 0. If that's 0, that's going to end up being 0. So let's see what this is at 0. X equals 0. So if we plug 0 in, the left side is just going to be 4. Here we got, if we plug 0 in, that's going to be negative 2. This parentheses is going to be positive 2. Plus, if we plug 0 in here, this whole thing's just going to equal 0. And same thing with the last one. That would all just end up equaling 0 if one of the terms is 0. Okay, so now we can solve this out and see what we get. That's 4 equals negative 4a. And a is going to be negative 1. Okay, another number here that would make this equal 0 would be negative 2. If we put negative 2 in for that x, it would eliminate. So let's see what this equals at negative 2. So now we're plugging negative 2 in for every x. On the left side, negative 2 squared is 4, plus another 4 would be 8. If we put negative 2 in here, that term's gone. If we put negative 2 in here, that term's gone. This last one, though, we'll have something. We'd have negative 2 in for that x. If we put negative 2 in there, we got 3 times negative 2 is negative 6. Minus another 2 would be negative 8. We should be able to solve this one now. Multiplying those two together, we get 16c. So c looks like is 1/2. All right, we got one last one we got to figure out here. The last number that makes x equal 0 in this would be putting something in for this one. And there it would be, looks like 2/3. If we put 2/3 in there, that one would equal 0. So let's see what this equals at 2/3. So putting 2/3 in that first one, we'd have 2/3 squared plus 4. 2/3 is going to make that equal 0. This b one, though, is still there. We'd have 2/3 times 2/3 plus 2. And then the last one, that c one's going to eliminate 2 and be 0. So now we got to figure out this one. A little bit harder, but not too bad. A lot better than solving a system of 3 equations here. So this is going to be 4/9 plus 4. If we get a common denominator multiplied by 9/9 would be 36/9. On the other side, let's add 2/3 and 2. That would be the same as 6/3. So we'd have 8/3. Adding together this side, we got 40/9. Multiplying on this other side, we got 16/9. And then multiplying by the reciprocal, there looks like b would come out to be 40/16. That's also the same as dividing both by 4, 10/4, and we could reduce even further. Looks like it'd be 5/2. So now we got all our constants. Okay, now we want to plug those back into the integral, split it up in these 3 here, and I think we got it. So now insert in everything here. So a we found out to be, what was it, -1. B we solved out to be the 5/2. and the c we solved out to be 1/2. Now from there, it's doing what we did on the other problems to get it. You get negative natural log x plus 5/2. Now you got to be a little bit careful on this one here. This integral would look like this, and we'll come back to that one. And then if we integrate this one, it'd be 1/2 natural log x plus 2. And the reason I hesitate on this one, when we integrate here, you got to think chain rule now. What would happen if we took the derivative of that? There's that extra 3 in there. So that's going to produce one extra term when we integrate that. So this is going to be antiderivative would be natural log of this. But if you think about what we get on the derivative there, that would be 1 over 3x minus 2, what we got here. But if you did the derivative of the inside, there's going to be an extra 3. We don't have that extra 3, so there needs to be an extra 1/3 out there. And so our final answer then, if you were to combine those two fractions together, this would turn into 5/6. And that would be the antiderivative or answer for that one. Okay, so ones with 3, we can do those too. All right, once you pause the video, try out number or this problem here and see what you come up with for this one. All right, if you split this one up correctly here, this all factors here to x times 2x minus 1 times x plus 2 in some order there. Okay, next thing, if you split it into the partial fractions and solve here, this one out. You find your a, b, and c and did it right here, did it correctly. You should have found out that this one is going to be 1/2. This one, it comes out to be 1/5. And this one you should have got negative 1/10 if you did it correctly. Then integrating that kind of ends up actually being a lot of the easy part here. Be careful on this middle one again. The chain rule is going to apply here, so there's going to be an extra 1/2 that gets produced there. So this will end up being 1/10. And then this last one plus c. So that should have been the answer that you came up with if you did it correctly there. Okay. What happens if the degree of the numerator is not less than the degree of the denominator? Because all of them we've been looking at so far, there's been a higher power in the denominator than the numerator. So if they're even, or if the numerator is bigger than the denominator, what we have to do is divide. Okay, we got to divide first. So the first step on this one, we want to divide x squared minus 1 by x squared minus 16. Okay, so we want to see what gets produced when those are divided out. So what we want to do is see how many times does that divide in there. So first thing we want to do is see how many times does x squared go into x squared. It would go in one time. So then what we have to do is multiply that back out. We multiply this times this times this, and see what we get. So if we multiply 1 times x squared, we get x squared. If we multiply 1 by negative 16, we get negative 16. Okay, so now, just like you do in regular long division, we want to subtract these and see what we get. So if we take x squared minus x squared, that is 0. If we take negative 1 minus a negative 16, that's going to actually end up being adding there. That's going to give us 15. Okay, so that ends up being our remainder. So we get 1 remainder 15. Okay, now if you think back to what we did when you were younger, once you found that remainder, then what that means is that remainder is 15 over what you were dividing by, which is x squared minus 16. So this, what we started with, divided out, looks like that. And so what our integral is going to become then is what is the integral of this, since that's equivalent to what we started with. All right, so what we're going to do now is once we've divided that out, we know these are equal to each other now. 1 plus our remainder was 15 over our denominator. Okay, so the first integral here should be super easy. Integral of 1, that's an easy one to find. What's left here though still has to be solved out, and that's where the partial fraction comes in now. So now we want to factor that and see what's left here. So if we were to factor that, we're going to have x minus 4 and x plus 4 there. So now we got to do the partial fractions like before. So over on the side somewhere, let's figure out what that would be. You'd have 15 x plus 4, x minus 4 equals a over x plus 4 plus b over x minus 4. Go through and do the same thing. If you multiply to get the common denominator now, we got 15 equals a times x minus 4 plus b x plus 4. Look at the two numbers that would make that 0, 4, and negative 4. So if we were to plug 4 in, we'd get 15 equals, this would just be gone, that'd be 0 if we put 4 in. The other one would be 8b. So looks like b is 15 eighths. If we were to do the other number, negative 4, then this one's going to be gone, but this other one would be negative 8a. And so a looks like it's negative 15 eighths. So now writing this out, we have 1 plus a was negative 15 eighths over x plus 4 plus the other one was positive 15 eighths over x minus 4. And now we should be able to integrate each one of these. Integral of 1 is just x, or antiderivative, I mean. Antiderivative of the next one would be negative 15 eighths natural log x plus 4. The next one would be 15 eighths natural log x minus 4. And always our plus or constant there. And that would be the answer. Okay, so if the numerator is equal to or bigger in degree than the denominator, divide first. All right, here's another example where you'd have to divide first. See if you can do this long division and figure out what this would be. So see if you can divide and find out what this one's going to be. Now, one thing, be careful here. It is missing that degree of x to the first power, so you kind of got to think of it as this when you're dividing. Okay, let's see how you did on this long division here. So you want to see first how many times is x squared going to x to the fourth. If you divided those, you'd get x squared. Now you got to multiply that back through all three of these. So if you multiplied back through, you would get x to the fourth. X squared times x would be x to the third. X squared times negative 2 would be negative 2x squared. Now we got to minus all that and see what we get. So these would just be 0. X to the third minus x to the third, that's going to be 0. X squared minus a negative 2x, that's like adding, so that's going to be 3x squared. All right, now you got to, this one didn't happen on the last one, we got to drop down these other terms here. to finish doing this. Okay, so now we want to see how many times does x squared go into 3x squared. So if we divided those, we'd get 3. Now we got to multiply that 3 back through to all these. So if we multiply back through, we'll get 3x squared. 3 times x is 3x. 3 times negative 2 is negative 6. Now we got to subtract again. So if we minus these, that one's 0. There's not going to be anything left there. 0 minus 3x is going to be negative 3x. 1 minus a negative 6 is like adding, that'd be plus 7. That's our remainder here. And so our answer is going to be x squared plus 3 plus this negative 3x plus 7 over what we are dividing by x squared plus x minus 2. All right, so now that we have it split, now you go into the partial fractions and see what you get there. So now pause again, see if you can do the partial fractions for that factor it, and then see if you can get the partial fractions out. All right, let's see what you got for partial fractions here on that one. If you factor it, the negative 3x plus 7 over this would factor to x plus 2 and x minus 1. And so you got to figure out what are these two going to be. Okay, so multiply to get common denominator. This first one I have to get multiplied by x minus 1. The second one by x plus 2. Okay, so now think about the two numbers here. One number would be at x equals 1. So if we plugged 1 in everywhere, the left side would be 4. This term's gone. Our other one would be 3b. And so b is 4/3. The other number we'd want to do is negative 2. So if we put negative 2 in, the left side's 13. This one's just going to be gone here. So and put negative 2 in the other one, we get negative 3a. Divide a is negative 13/3. So now we can write out our integral here. Our integral from what we had before. We had x squared plus 3 and then plus our partial fractions here. So now that we know what this splits up to be, we had a over x plus 2 plus b over x minus 1. And so if we plug those numbers in now, this is going to be negative 13/3. And b is going to be 4/3. So now we can finally solve this one out. The first two, those are just easy antiderivatives you've been doing forever. This should equal 1/3 x cubed. Next one's 3x. Okay, but now we get into our natural logs again. So minus our constant natural log x plus 2. And our other one, our constant, there's 4/3. Antiderivative, the rest of it would be natural log x minus 1. And that would be our answer. So if the numerator is bigger than the denominator, divide first, then find it out. Okay, one last thing, if you end up having multiple terms that come out, and what I mean by that is a repeated factor, then you need to have multiple ones for each degree of that. So for example, say you had 1 over x plus 4 squared as your one that you wanted to do. Then if you split it into partial fractions, you're going to have an a for x plus 4. You would also have to have a b for the second one of those squared. So whenever you set it up, you have to have a variable for each degree. If this would be to the third, then you'd have to have a third one here of x plus 4 to the third power. That's just how you have to do it when you do fraction decomposition, split up into the partial fractions. So let's look at one last one where that would come up. And this one, okay, first off, we can see if we were to multiply this out, the numerator is bigger than the denominator. So we have to start by dividing this. We got to take x to the 5th plus 1 and divide it by x to the 4th plus 2x cubed. Now, in this one, there's a bunch of missing terms here, so we got to think of this as plus 0x to the 4th, 0x to the 3rd, 0x squared, 0x plus 1. What's that going to divide out to be? So what would we get if we took this divided by this? Would there be 1x left? If we multiply that, back that through, you get x to the 5th. If you multiply to the next one, you get plus 2x to the 4th. We got to subtract those. So we get x to the 5th minus x to the 5th, 0. 0 minus 2x is going to be negative 2x to the 4th. Drop the next one down. Okay, now divide again. What's this divided by this? We get a negative 2 up here. Multiply that back through. We get negative 2x to the 4th minus 4x to the 3rd. We got to subtract again. And those ones cancel on the left. The other one, 0 minus negative 4, is going to be positive 4x to the 3rd. Now drop down what's left here. The only thing left is 1. We can't divide anymore because x to the 4th doesn't divide into that. So what's left there is our remainder. So we end up with a remainder of this. So now let's write this out as our partial fraction. So we would have an integral of what we got up on top here, x minus 2 plus our remainder of 4x cubed plus 1 over what we are dividing by, which was the x cubed x plus 2. Okay, because this and this are the same. Okay, so that's our integral now. Now we got to split that up into the partial fractions because this part is very hard to integrate. And so what we're going to do is think of, okay, what are the terms there? We got 4x cubed plus 1. Okay, and all this equal to, now the factors here would be x, because there's 1x there. We need a second one for the next degree, x squared. We need a third one for the x cubed, because that's the biggest power. And then finally we need one for the other one, the d over x plus 2. Okay, so now we know if we multiply by the other ones, it should equal this out. So if you get the common denominator here, this first one, a, would have to get multiplied to get a common denominator by an x squared, and it would need the x plus 2. The b one would need one additional x, plus it would also need the x plus 2. The c one already has x cubed, all it needs is the x plus 2. And the last one, the d1, would just need the x cubed to get a common denominator. All right, now let's figure out the numbers here that would make this equal 0. There's only two of them here, 0 and negative 2. So what is this first at? 0. If we plug 0 in, the left side's just 1. And this term would be gone. This term would be gone. This term would be gone. The only one left would be this one. So if we put 0 in, that would be 2c. And so we know c is going to be 1/2. Okay, the other number that would eliminate this would be negative 2. So what is this at? Negative 2. So if we were to put negative 2 in, the left side over there, negative 2 to the third power would be negative 8. Times 4 is negative 32. Plus 1 is negative 31. Going through, this would be gone, this would be gone, this would be gone. The only one left is this d term, so we'd have negative 8d if we put negative 2 in there and cubed it. So we can find d as well here. D ends up being 31 over 8. Now, those were the only two numbers that kind of eliminated stuff here, but we haven't found b and a. So what we're going to have to do is kind of plug those back in here and figure out what we would have left. So we got to come up with something that would still have A and B in there that we could plug the C and D values in for too and find A and B. So since we don't have any other numbers that are going to eliminate, just try to pick some easy ones that would give us an easy equation to work with that we could solve out. For example, an easy number that we could plug into all these, it won't eliminate anything, but like 1. 1 would be an easy number we could just plug in there and get some equations out. So if we plugged 1 in, the right side is going to be 5. The left side, we would have A times 1 times 3. Again, nothing's going to eliminate here. If we plugged 1 in the next one, we get that. If we plugged 1 in the next one, we get that. And 1 in the last one, we get that. So our equation would come out to be 3A plus 3B plus 3C plus D. Now, the thing though is we know what C and D are, so we could plug those in and get an equation that's a little bit easier here. So if we plugged in those values, we know C is a half and D is 31/8. Now we could simplify that down to an equation that just has A and B, so we could get 3A plus 3B. If we add those and minus from 5, that's going to come out to be negative 1/8. Okay, similar, we could pick another easy number to plug in there that would give us another equation we could use, and then we can solve for A and B. So another easy number might be like negative 1. So plug all those in there. So if you would go through and plug in negative 1, the left side is going to turn into negative 4 plus 1 or negative 3. Okay, and now plugging in for the rest of them here, we would get A to be negative 1 squared is positive 1, and negative 1 plus 2 would also be 1, so we get 1 and 1. For B, plug in negative 1 in there, we'd have negative 1 and positive 1. Doing it into the next one, we just have C times 1. And if we did it on the last one, negative 1 cubed is negative 1, so we'd have B times negative 1. Okay, so going through, this equation would turn into, this should be minus a B. Again, plug in our values for C and D here. And simplify that equation out, would turn into A minus B equals, if you minus 1/2 and add 31/8 over to the other side, then that's going to come out to be 3/8. And so now we got two equations here, a system of equations that we could solve to do this. If you also know how to do like matrix on a calculator, that would also work on these types of problems where you have lots of variables to solve. But now we'd want to solve that out, see what we get. we can find our a and b and then finally go through. If you solve those out, a comes out to be 1/8 and b comes out to be -1/4. Now we can finally split into our partial fractions and do this. Now, I don't know that you'd ever see this one on the AP test, but going forward, if you take a math class, I just want you to know how you'd go about doing this in order to do it. So we'd end up with this as our partial fraction. Now that we know all of the terms here, and finally then we can integrate and solve this one. Okay, and by now we kind of know how to do that. All right, I want you to try some of these out. There's not going to be any quite as hard as that last one we just did, but kind of gives you an idea of what to do on these.